Okay, good morning. So what I want to think about now is when you're combining non-metals with non-metals. So again, just as a reminder, everything that's in green here is what's known as a non-metal. Now, and also as well, hydrogen, even though it is part of group 1, it would be considered a non-metal as well. Now, if we think about, so imagine we have carbon. Okay, so we have a carbon here, and we add this and we have hydrogen. So what way is carbon and hydrogen, what way are they going to bond? Now, one way to kind of think about this problem is to think about, if we think about carbon, so where is carbon on the periodic table? It is within group 4, okay? So remember, if it's within group 4, that means that it has 4 electrons in its outer shell. So it has 1, 2, 3, 4 electrons. Now, that also means that carbon needs 4 electrons. So it has 4 electrons in its outer shell. It needs 4 more electrons in its outer shell. So carbon has 4 electrons and it needs 4 electrons. Remember, the outer shell of carbon, it wants to have 8 electrons out there. If we think about what does that mean? Well, it means that carbon has the ability to form, so if it needs 4 electrons, then that means it has the ability, so it has the ability to form 4 bonds. Okay, so that means it can actually form 4 bonds. So if it needs, so it can share 4 electrons with either with another atom, or it can share 4 electrons with 4 other atoms. Now, if we think about hydrogen on the other hand, so hydrogen is a group 1 element, so that means it has 1 electron in its outer shell. Now remember, in the case of hydrogen, hydrogen needs, so it has 1 electron and it needs 1 electron. Okay, so that means because it needs 1 electron, it has the ability to form 1 bond. So it can only bond once with another electron, or with another atom. So if we think about, if we have a hydrogen and a hydrogen, that's just going to form, it's just going to form 1 covalent bond like that. So what's going to happen is you're going to have, so imagine this is your nucleus of one and this is the nucleus of the other. So this is the orbital of one and then this is the orbital of the other. Each one has 1 electron. So this electron and this electron, they'll share with each other, and then you'll have this, what's known as a covalent bond. So basically, like, a way to think about it is, so whatever number of electrons the atom needs, that means that it has that same number of potential bonds that it could form. So carbon, like, it needs 4 electrons, but that means that it can bond, or it can connect with up to 4 atoms. So it can. So let's say if we go back to this then. So let's say we have carbon and we have hydrogen, and we're trying to figure out from the periodic table, like, if we combine carbon and hydrogen, what's the ratio? Like, how many carbons will there be for every hydrogen, or how many hydrogens will there be for every carbon, if we try and figure that one out? So if we think then about carbon and hydrogen, so carbon, so it needs 4 electrons in its outer shell. And if it's going to pair up with hydrogen, each hydrogen atom can only provide 1 electron because it only has 1 electron in its outer shell. So when you think about it, if carbon wants to have a full outer shell, it needs 4 electrons. If each hydrogen can only give 1 electron, then that means that carbon will need 4 hydrogen atoms in order for it to have a full outer shell. So what we can say is that, so carbon, for example, if we have 1 carbon, then we're going to need 4 hydrogens. So we'll have, let's say, this bond, we'll have another bond, carbon, another bond of hydrogen, and another bond of hydrogen. So what these lines here, what they mean is, basically what we have is, we have, So if you imagine this hydrogen has one electron, so that's the electron there, and it's going to share it. It's going to share an electron then with carbon. It's going to share. So hydrogen is going to share one of carbon's 4 electrons, and carbon is going to share one of hydrogen's 4 electrons. So this sharing of electrons, this is what's known as a covalent bond. Okay, and the same here. So let's say this hydrogen here will have 1 electron to share. Carbon will have 1 of 4 electrons to share. So you're going to get this sharing here between these two atoms. And again, this is a covalent bond as well. The same thing is going to happen here. This hydrogen will have 1 electron. It'll share it with the other electron the carbon have, and this is a covalent bond. And then the same thing is going to happen here. Okay, and so these are all what are known as covalent bonds. So potentially what that means is that, so if you take carbon for example, so you can just have carbon, so it can bond, so you can kind of write it like this, so it can bond with up to, because it needs 4 electrons in its outer shell, it needs 4 more in order for it to have 8. It has the potential to connect, to bond with up to 4, to make 4 bonds. Okay, so it has the ability to form 4 bonds. If we take hydrogen then on the other hand, so hydrogen only has the ability to form 1 bond, because hydrogen only needs 1 more electron. So as a result of that, it only has the ability to form 1 bond. Okay, and essentially, you know, that's what they have here in your textbook as well. Okay, so you have carbon here. It can connect. It can form up to 4 bonds. Hydrogen only can form 1 bond. So if you want carbon and hydrogen to connect to each other and bond together, you're going to need 4 hydrogens and you're going to need 1 carbon. And that's what you'll get, this kind of a connection here. And this is what's known as methane. So the name of this molecule is what's called methane. And another way that you can write it like this: carbon, and it's bonded to hydrogen. So it's carbon bonded to 4 hydrogens. So again, this just represents the individual atom of hydrogen, for example. This represents the individual atom of carbon. And then these lines between the carbon and the hydrogen represents the bonds. So it just means that here you have an atom of hydrogen connected to an atom of chlorine, and this line represents the electrons that they share with each other. And this is what's known as methane. And also as well, we can see as well then that we can look at the ratio. So we can also write this, we can write it like this. So you can have carbon, so CH4. So what this means is again, the same thing. The C part represents the fact that there's a carbon atom in here. The hydrogen represents the hydrogen atoms, and this small subscript 4 means that there are 4 hydrogens present, 4 hydrogens connected to this carbon. And this molecule, so the name of this molecule is methane. That's the name of the molecule. Okay, so what I want you to do now, I just want you to pause the video. So have a look at this. So I want you to complete this table. So what we're doing is, so let's say if we're picking the element hydrogen, its chemical symbol is H. So if we have a look on the periodic table, we can see there's its chemical symbol. Its chemical symbol is H. It's a group 1 element, so it's a group 1 element. The electrons that it needs, so we know if it has 1 electron, in its outer shell. So remember, imagine this is the nucleus of a hydrogen atom. It has one shell. Okay, and this shell, the first shell, the one nearest to the nucleus, it needs 2 electrons. But you can have up to, so for example, you can have the second shell can hold 8, and the third shell can hold 8 as well, just depending on the type of atom it is. But with hydrogen, it only has 1 proton and 1 neutron, so therefore it only has 1 electron. So that 1 electron will be on the first shell out from the nucleus. So therefore, its group number is 1. The electrons it just needs one more. So therefore its combining power is 1. So it can only form one bond. And if you want to show, so you can show it like this. So you can represent a H, and then just an arrow represents the number of bonds that it can form. The same with carbon. So again, carbon, if we look at where carbon is on the periodic table, so carbon is here. Okay, we can see its chemical symbol is C, so that's on the periodic table. It's a group 4 element, so it's within this group 4. Remember, the vertical columns are known as the groups. The electrons that it needs 4. So imagine this is your carbon atom. You're going to have, remember, you're going to have 2 electrons in the first shell, and then the next shell out, it can hold 8, but it's going to have 4 electrons. 1, 2, 3, 4. Okay, so with carbon, we know that it's group 4, so therefore it has 4 electrons in its outer shell. Now we know as well that carbon, for example, if we look at its atomic number, see this smaller number is 6, so that means that it has 6 protons in the nucleus, but it also means if it has 6 protons in the nucleus, it also has 6 electrons in total. And these are the 6 electrons, 1, 2 in the first shell, 1, 2, 3, 4 in the outside shell. So again, we can represent it, so it needs 4 electrons. If it needs 4 electrons, then it has a combining power of 4, so it can connect up to 4 times, or it can form 4 bonds, and therefore we can represent it like this. We have a C, and then each arrow represents the one of the 4 potential bonds that it can form. So what I want you to do, I want you to fill out this table. So do exactly the same for nitrogen, oxygen, sulfur, and chlorine. So pause the video and work through that now, and then we'll have a look and we'll work through it. Okay, so let's work through all of these. So if we think about nitrogen, for example. So nitrogen, its chemical symbol is N. So when you look on the periodic table, and so if we have a look here on the periodic table, maybe I might just bring this down here so I'm not going back and forth. So let's have a look at this. Okay, so nitrogen. So nitrogen, where is it on the periodic table? So here it is here. So nitrogen, and we can see its chemical symbol is N, so therefore its symbol is N. The group number, so what group does nitrogen belong to? It belongs to group 5. So we can see here, it's written under group 5. So we can just write in 5 in here. The electrons that it needs, so remember, if it belongs to group 5, so imagine this is nitrogen here, it means that it has 1, 2, 3, 4. It has 5 electrons in its outer shell. Remember, the outer shell for nitrogen is going to need 8 electrons. So as a result of that, so the electrons that it needs, if it has, so it needs 8. We minus 5 from that. It has 5, so therefore it's going to need 3 more electrons. So it needs 3 electrons. And so therefore it's combining power. So if it needs 3 electrons, that means that it can form up to 3 bonds. It has a combining power of 3. So therefore we can just write it like this. So we can have a little n, simple like that. So 1, 2. Okay, so I write that now. 1, 2. I'll just write it out here. So it can have, it'll be something like this. Okay, sorry now. Okay, so it'll have a combining power of 3. So it'll be written something like this. So oxygen then, if we think about oxygen, where is it on the periodic table? Here it is here. We can see its symbol is O. So oxygen, the symbol for oxygen is O. Its group number, so again, if we look on the periodic table, its group number is 6. So it belongs to group 6. So it's group number 6. The electrons it needs, so remember if we have oxygen, so imagine this is oxygen here. So if it's in group 6, it means it has 6 electrons. So it has 1, 2, 3, 4, 5, 6. So it needs 8, so minus 6. So therefore it's going to need 2, so it needs 2 more electrons. So the electrons it needs 2. If it needs 2 electrons, it has a combining power of 2. So that means it can share an electron with 2 other atoms, or it can share 2 electrons with 1 other atom. So again, its symbol will be an O. I'll just write a circle around it, and then you can just write 2 arrows like this. So, okay, I don't know why this is not working for me. So, okay, so you have 2 arrows like this. So you have the oxygen atom, and then each arrow represents the potential bonds that it could form. So it has a combining power of 2. If we think about sulfur then, so if we have a look for sulfur, so here's sulfur on the periodic table. So its chemical symbol is S, we can see here. So again, sulfur, its chemical symbol is S. Its group number, we can see that it belongs to group 6. See here. So it belongs to group 6. It has the same number of, it needs the same number of electrons as oxygen. Oxygen is also group 6, so it's 2. Its combining power then, if it needs 2 electrons, it has a combining power of 2, and then you would just write the sulfur. It would just be like this. Okay, so that's sulfur, and that's its combining power. And then if we think about chlorine then, so where's chlorine? So here's chlorine on the periodic table, so it's group 7. So chlorine, we can see its chemical symbol is Cl. So again, chlorine, its chemical symbol is Cl. Its group number is 7. It's within group 7. So if it's within group 7, so imagine this is chlorine, so that means it has 1, 2, 3, 4, 5, 6. It has 7 electrons. It needs 8, so 8 minus 7 is equal to 1. So it needs 1 more electron to fill its outer shell. So it needs 1 more electron. If it needs 1 more electron, then it means that it has a combining power of 1. So chlorine, then you'd write it like this. So it just has a combining power of 1. Okay, very similar combining power to hydrogen. It has a combining power of 1. Okay, so that's what we mean. So all we really spoke about then there was just the combining power of, so when you're combining non-metals. So remember, non-metals are these guys that are in green on the periodic table. So you're looking at like what way will they combine. So again, you look at how many electrons do they need in their outer shell, and whatever number they need in order to have a full outer shell, that's an indication of how many bonds it can actually form. So if we take carbon, for example, it has 4 electrons in its outer shell. So therefore it has the potential to bond up to 4 times. It can form 4 other bonds. And we've seen that if we take carbon and hydrogen, so hydrogen, for example, it's group 1 on the periodic table. It has 1 electron in its outer shell. So carbon can form 1 bond. So if you wanted to combine carbon and hydrogen together, you would need 4 hydrogens for every 1 carbon. So hydrogen can form up to 4 times with carbon. Carbon can form 4 bonds with hydrogen. So you'd have a molecule that's something like this. So that's what's known as methane. So remember, each of these lines here represents what's known as a covalent bond. A covalent bond is where 2 atoms share electrons with each other so that their outer shell is full. So that's what we mean. So by combining powers, that's how you can start to work out then, like if you have carbon and nitrogen, for example, or oxygen and nitrogen, how will these atoms combine together? Like what kind of bonds will they form? So that's what this is kind of leading up to, and it's just giving you an indication of how you can use the periodic table to make predictions about how different atoms on the periodic table will form particular types of bonds with each other. Okay, so guys, thank you for listening.